Today we're going to talk about the endocannabinoid system and autism, and these two things are closely related. Um, there's the solutions that we're looking for autism, let's say, how do we kind of treat the cause of autism? Well, that's going to have to do with this bacterial hijack. And the more that we figure out kind of what this bacterial hijack is, the more ability we'll have to be able to break that loop. But the endocannabinoid system in autism is an important discussion. And I think that you guys, if you have autistic kiddos, are going to go, wow, that's interesting. And if you don't know about the endocannabinoid system, this will be a little bit of a journey into the endocannabinoid system. So, humbly said, what I do every day is I research human function. And I'm thought to be top 5 in the world on the endocannabinoid system that we're going to talk about today. I was a TEDx speaker on the endocannabinoid system. I told all my fellow TEDx people, I said, my talk will never see the light of day. And they all laughed at me. They said, ha ha ha, Chip, yes, you will. Your talk is very good, very informative, very scientific, very much what people need to hear. And TED did not allow my big talk because the endocannabinoid system, frankly, is so threatening to pharma and the pharmaceutical industry because it's the system of the future. It's really the target. It's what nature targets, I guess is the best way to tell you. And by nature influences through this system. And this system is vast and broad and does a whole lot of stuff in our body, which we're going to talk about. So let's dive right into the endocannabinoid system. And I don't know if you guys can see that or not. Let's make sure that we're on the right. There we go. That looks right. Okay, everybody can see the slides, right? Yep, I can tell you guys are all saying you can see the slides. So we're going to dive right into the endocannabinoid system and autism. We've got to talk a little bit about what the endocannabinoid system is first. And I like to use analogies to teach things, right? And so if I ask you, hey, how do you work? You're going to give me an answer, right? And that's going to be based on your understanding and kind of background and knowledge. But if you ask somebody else right next to you, hey, how do you work? Their answer's kind of going to be different, right? Different than yours. And my answer is going to be different. And literally almost everyone that you talk to will have a different answer about how you work. That to me is interesting, right? Why can't we describe how we work? There's a lot of chaos and confusion around how you work, and that seems to me to be on purpose, right? So we can't kind of figure it out, so we can't see the game, so to speak. It's pretty easy. We all can, is it that we're incapable of describing how we work? No, we're smart people. We know how to do this. So if I ask you how your car worked or how your motorcycle worked, again, we're all going to give about the same answer to that, won't we? So we'll all say, yeah, our car has got an engine in it, gets down the road, runs on gasoline. I steer it with a steering wheel. I got a radio. It does some other stuff. It takes care of itself, right? So we'd be able to describe in pretty sophisticated detail how our car works. So let's do this, all right? Let's use a car, a vehicle, as our frame of reference for the endocannabinoid system. So again, you can be described like a vehicle. You have an engine, you have a hypothalamus hippocampus, which we'll call the computer in your vehicle. And we all understand that in our car has a basically computer, in you that's a hypothalamus hippocampus, but it has a computer. And that computer is always watching every system in the vehicle. It's always looking. It's sensor arraying, right? So it's looking for things going wrong or right or whatever. So it's always sensor arraying. And then if things change or things need to be changed, whoop, whoop, it goes out. The computer goes out and makes those changes through the electrical system, right? So the electrical system is kind of always sensoring. And then the electrical system is the ability to make change. It is the mechanism of action. So guess what? That's what the endocannabinoid system is. It is basically that system inside of you. So you have a computer, and that's your hypothalamus hippocampus, and your computer is always watching every single system in your body for change and for need to be changed. And again, that is the endocannabinoid system. The endocannabinoid system is like our computer and our electrical array. It is our master regulatory system. But that's how it works inside of us. So it's a big high level system that's always trying to make these changes inside of us, right? And balance us really so we get the most mileage out of our vehicle, the most gas. Pretty cool. So again, to extend this, what is the engine in our vehicle? And we're going to talk about some stuff that's not really endocannabinoid system real quick, but we'll tie it back together all at the end because this is important stuff. So what is the engine in your vehicle? Well, it turns out that that's something called mitochondria, okay? Mitochondria are in almost every cell inside of us. They're interestingly not in red blood cells. I think that's interesting, but they're in almost every other cell in your body. Some cells will have thousands of mitochondria, thousands of these little engines. Well, again, they're the engine in our vehicle, so we all kind of learned that in high school science. If I ask you, where do you hold consciousness? You're going to probably say, oh, my brain, Chip. I hold consciousness in my brain. Okay, what's a brain? It's a collection of cells. Those cells are called astrocytes, and those cells only know that they are astrocytes and what to be because of the mitochondria inside of them. So we arguably hold consciousness, we hold intellect, where would our crossover to God be or spirit? This is a logical point, right? So mitochondria are pretty important to understand and pretty important to optimize. So there's ways that you can optimize a mitochondria. But the most important thing that I want you guys to understand about them is fuel, okay? So your body kind of needs water-soluble stuff, and so mitochondria will run on water-soluble fuel, and that's glucose or ketones, right? Depending on how fasted you are, it'll be one of those two things. But glucose, the way that most of us run right now, which isn't good, in the future, probably ketones. So, and that's our most inefficient way. So that's the most inefficient way to run your engine is on glucose or on ketones are better, but on glucose, okay? So the second sort of way that we run our engine, and these are like fat soluble, oil soluble. So we've got water soluble, least efficient, with glucose. We've got fat or oil soluble, and those are fatty acids. So those are saturated fat, basically will run you. And saturated fat is about a 1 to 40 exercise. Glucose is 1 to 2, so you only get 2 units out. Fatty acids, 1 to 40, right? So you're way more efficient if you're running on fatty acids. And then the last way a cell will run, or the mitochondria inside of a cell will run, is on light, okay? But you have to have a chloroplast to do that. We flip light and UV frequency, you can think of it, all around us all the time. You're kind of like a big antenna. So, that's a little woohoo for most people. We'll save that for later. But you absolutely have cells inside of you that run on light. And those would be the most efficient. That's the most efficient way to run a cell. The graphic over here on the right is it's sort of a description of a mitochondria, but you can see all the stuff that goes on inside of a mitochondria. And you have those little Roman numerals down at the bottom. Those are called respiratory chain reactions. And there's 4 of those that have to be optimized. Like autism, I think it's 1 in 4. So in autism, it's, very correlated to have issues with respiratory chain reaction number 1 and number 4. And when you have that, this causes a lot of oxidative stress. So you can see those little ROS guys down at the bottom. That's oxidative stress. And this really happens when you have a cell that's sort of stuck over here in glucose, but everything, all of its signaling stuff around it is telling it to become more efficient and telling it to basically run in better mode. And again, that's what causes oxidative stress, all right? Okay, what else do I need to tell you about this graphic? I think that's it. You can see like catabolism. So when you eat a meal, you kind of are building things, and you'll build things for 5 hours. We're going to talk about this in a second. But after that, you need to be able to tear things down. So at times, a cell will be producing things, right? So it may be producing proteins, for signaling or whatever. That's called anabolism. So that's production of things. Catabolism is where that cell's tearing down things. And sometimes it's doing, both at once. But anyway, important concepts. Okay, another important concept is something called fasting versus something called fed. So, I like to sort of tell a story around this. So first of all, we all run by the sun. So we have a 24-hour clock that we run on, and then we have other clocks that are kind of associated with it. But it's all associated. Every clock inside of you is associated with the sun and your relationship with the sun. Now, if you're spiritual, spell that S-O-N, which gets really interesting and close to home, doesn't it? Which is really, really cool. But you have a tight relationship with the sun. And the sun literally sets a 24-hour cycle inside of you. This cycle is super duper important because your body is really good at sort of doing one thing at once, right? So it can do other stuff, but it's really wants to focus. And it wants to focus on, let's say, building hormones at certain times, or building your cell walls up and structure at certain times, or building your immune mediators, or whatever. But you get the idea. And literally, this is a scripted event. So every day it's the same thing for you, provided you don't go on shift work and stuff like that, which will kind of mess it up. But for most part, for you, every day it's the same script that happens, okay? So we go through this same script of stuff. Now, the most disruptive thing that we do every day is eat a meal. When we eat a meal, we are stopping that script, and you might be building hormones or you might be building immune mediators, but you're stopping that script in order to deal with a meal. And it's very expensive on you. It's very expensive on your body. It takes a lot of energy to deal with food that you just ate. And again, the worse and more food that you eat, the harder that it is for your body. So you have to disrupt this symphony. And when you do so, you disrupt it for 5 hours. Your body just kind of, when you eat, your body goes to sleep almost. You drop your immune system. Your body kind of goes to sleep. And you work on your meal for 5 hours. During this time, you do not burn fat. You can't, okay? Because you're storing it, you're working it. That's basically part of kind of what the process of your body is. Fat is really important to your body, so your body's going to optimize it. It's going to store it in your fat tissues. It's going to remodel triglycerides, and your liver is working really, really hard during all this time. When you eat, you also begin to make cholesterol, and you'll make cholesterol for 5 hours during this process, okay? When you eat, you drop your 2 ways you have to kill cancer, and you drop them for 5 hours. You kind of just drop your immune system. I mean, you still have some immune stuff going on, obviously, or you'd be dead, but you kind of drop your immune system. What does it cost you to eat? It costs you a lot of aspects of your immune system. And again, this is really understand this principle if you're trying to lose weight, let's say, okay? Because again, if we eat breakfast and we have this 5-hour clock, right? And so we're not going to burn any fat for 5 hours. We're going to run on sugar for 5 hours. And so ticky, our clock starts. And then about the time we're getting ready to start burning fat, we eat lunch. And about the time we getting ready to burn fat, we drink that Coca-Cola or that Pepsi or that energy drink, boom, in the mid-afternoon because we're tired. And then about the time that we're about to pop out of that, we eat dinner. And then we eat that snack right before we go to bed. So most of us, we might have, 4 hours in the evening or the night, in the middle of the night, where we can kill cancer. We might have 4 hours where we have an active immune system. So this is why we stress and emphasize intermittent fasting so much, is it's so important to understand these principles. But as to the endocannabinoid system, again, when you eat, interesting things happen with fat, as do the rest of your body. A bunch of interesting things happen, okay? So this is super important, though. Everybody should know about fasting and fed. Teach your kids about fasting and fed. Read about fasting and fed. This is the most important health tip that I can give anyone, is to intermittent fast. It's, again, like I said, your body has 2 ways to kill cancer. When you eat, you turn them both off. Is chemo going to help you if you're eating breakfast, lunch, dinner, drinking Coca-Colas and snacks before bed? Not as much as if you were intermittent fasting. And so that's just, using pharma as an example. There's way better ways to deal with cancer than chemo, let's say. Although chemo works in its a way. All right, so what about the ECS, dietary fats, and the gut biome? So super important that you guys follow me through this. Complicated graphic, no test or quiz at the end, so you don't have to remember the complicated graphic. Just know that all this stuff happens. But this is really important if you've got an autistic situation, because this will kind of help you understand and appreciate the processes that happen in your kiddo that are a little bit different than the processes that happen inside of you. So when we eat, when anybody eats, when any mammal eats, and again, you're not a mammal, but when mammals eat or humans eat, when you eat fat, a very important thing happens right off the jump in your intestinal lumen. So when that fat hits your intestinal lumen, it combines with something called ethanol amine to form endocannabinoids. And an endocannabinoid will form from every single type of fat that you can stick on a triglyceride. And there's 9 or 10 of them. But every type of fat that you can stick on a triglyceride will build an endocannabinoid as soon as you eat it, as soon as it hits your intestinal lumen. By virtue of this, through your vagal afferent nerve, the biggest nerve in your body, you send feedback to your brain. And your brain sets a nutritional state for your entire body based on what you just put in your mouth and based on the amounts of fats that you put in your body. So if you're deficient in certain fats, you're going to know that. If you're sufficient in fats, you're going to know that. And if you're oversaturated in fats, your body's going to know that. And all of that intelligence goes into how you're going to basically shape and remodel your fat during the time when you're dealing with that meal. This also is super important because a decision has to be made in our brain, our central computer, our hypothalamus hippocampus, as to if we're getting enough. So if we're not getting the fats that we need, what happens is literally through control of the endocannabinoid system, we're allowed to develop a gut microbiome. That biome is managed within reason. It's out of control for most of us right now, but it's managed within reason by the endocannabinoid system. And the purpose of those little bacteria bacteria will eat things, right, that sometimes we're in competition for, but then they'll poop out useful proteins. And so we use those proteins to offset things that we're not getting in our diet, okay? So really cool system, fat-based, endocannabinoid system understands what you're eating, makes a decision, allows the biome to develop to a point to offset the nutritional deficiencies that it knows that you're not giving yourself. So isn't that cool? I mean, isn't that really neat, how all this works? And it allows you to, you could eat plastic for a while and still be okay. You'd have to have a pretty big gut biome. Now, super important thing, I don't have a slide on this, but just FYI, there's 4 categories of fat, let's say. So saturated fat, and it is inflammatory. So when you eat it and when you store it, it's going to help your body inflame, and you need to inflame at certain times. Monounsaturated fat, and that mainly comes from nuts, it's anti-inflammatory. So it will offset saturated. And monounsaturated and saturated, we kind of need to be in balance. We need to eat those fats in balance. The polyunsaturated fatty acids, there are omega-3s, and omega-3s are anti-inflammatory, and omega-6s, which are inflammatory. Now, if you look at your diet, our diets are mainly consist of, as to fats, saturated fat, and omega-6 because of all the corn in our diet. Those are inflammatory fats, and I guarantee if you look in your diet, you're not eating the monounsaturated and you're not eating the omega-3s that you need to offset those. And it's no, surprise that 80% of us will die of an inflammatory disease. And it's literally that simple. We just need to begin to offset our diet with omega-3s and with monounsaturated fat. But anyway, that's how important fat is to kind of how we work. And, we build, and this is what I'm going to talk about next, or we'll get into this, but we build, we'll get into that in a second. Okay, we build our immune mediators, our frontline immune mediators, we build from omega-3 and omega-6. So essential fatty acids, the things that we got to have, whoop, we use to build our frontline immune mediators. Okay, so, and we'll talk about that because that really applies to autism, but we'll kind of talk about the pathology there and what goes on and kind of why they can't do what you and I can do. So, every single autistic kiddo is going to have lower plasma levels of anandamide, and anandamide is your main endocannabinoid. So, anandamide is what THC from cannabis mimics, okay? So THC from cannabis mimics anandamide inside of us. And this is why some, autistic situations report good results with THC because they're supplementing into that system and they're giving those kiddos or adults something that they need, they're deficient in, right? So THC will kind of help offset anandamide. There's other ways to raise anandamide. I'm not, saying go out and do THC. That is just a solution, and at least here in like we're in Oklahoma. I live in Oklahoma, and we have a medical marijuana program, and so we're seeing a lot of autistic situations being helped with THC for this very reason. There's also two other deficient and significantly deficient endocannabinoids in the pathology of autism, and those are oleomide and PEA. I won't butcher the word for you. I just call it PEA, but it's basically the endocannabinoid you make from palmitic fat. So there you go, and that's what it is: palmitic fat and oleoethanol amide. So. Okay, so D6. So what is delta 6 desaturase? Okay, so remember I was talking about omega-3 and omega-6s, and again, omega-3s are anti-inflammatory, omega-6s are inflammatory. In order for and these are essential, you have to have omega fatty acids. You've got to have them because they help you build your immune mediators. So you hack up these fats and they're precursors for a lot of your immune mediators. So in order to deal with the fats, you have to express an enzyme. And this enzyme, this is almost the most important, well, it is the most important enzyme in your body right here, something called delta 6 desaturase. Again, if you cannot express this enzyme, you will not be able to deal with essential fatty acids, and you're going to have extreme consequences. And this is part of the pathology of autism, is that, again, FADS2 is the name of the gene that encodes for delta 6 desaturase. And look at this study, FADS1, FADS2, and evolved2 gene polymorphisms in susceptibility to autism spectrum disorder in Chinese children. So they're just showing that if you have a dysregulation in this FADS2 gene, you're not going to be able to honestly build an immune system in the way that most people do, okay? So D6 is responsible for cleavage of omega fatty acids, which are essential. Again, if you can't express this enzyme properly, you cannot deal with your essential fatty acids. Without delta 6 desaturase, you can't break down omega-3 and omega-6 fatty acids that you need to be able to do to build an immune system. FADS2 is also dysregulated in cancer. And again, I'm just tying this back to this bacterial hijack. And this bacterial hijack has to influence FADS2 in order for it to be successful. And it does, which again, Rex, if you have the bacterial hijack, you have this. But in autism, this is definitely part of the pathology. All right, so without delta 6 desaturase, you cannot build immune mediators. So I'll just read you guys a couple of these things here. Omega-3 fatty acid plays a massive role in the immune system. They strengthen the cell walls, help macrophages engulf pathogens. That's one method that you have to kill cancer. You want that going. And aid in eliciting a strong immune response in the presence of a virus, pathogen, or bacterial invasion. Well, flip that around if you don't have enough omega-3s, and what happens? Omega-6 fatty acids are substrates for escanoids and cytokine synthesis. So if you don't have enough omega-6s, you can't build direct immune mediators. They play a role in modulating inflammation, immune function, and vascular system development. So again, if these are dysregulated, if delta 6 desaturase is dysregulated, you're dropping your shields. You're an open, sort of book for pathological invasion, and you can't build much of an immune system. Well, if you've got an autistic situation, you understand that your kiddo has a different gut biome than you do, certainly. And the reason for this is so let's go back to this. What happens if you're not getting the right fats? What does your body do in the endocannabinoid system? If your body understands that you don't have the right fat makeup to defend yourself, it's going to use the gut biome to develop what it needs to defend itself. And that's exactly what happens in autism, okay? So they have a very unique gut biome because they need that butyric acid and that proponic acid in order to defend themselves and in order to build an immune system. Again, what are those things? Those are short chain fatty acids that bacteria signal with. And the autistic sort of system has picked those up and is using those as a shield and as a defense. Now, regrettably, in this situation, what happens is they all overproduce proponic acid. And proponic acid is literally what they use in rat models of autism. So they will inject proponic acid into a rat, and that will give the rat all the symptoms of autism. If they feed that rat salt, everything goes back to normal for the rat. Meaning that, at least in that instance, this is reversible. And if autism is, let's say, being exacerbated by a proponic acid situation, if we can get the proponic acid under control, yeah, I think that'll happen. We'll get the autism under control. Now, one of the ways that if your kiddo has this going on, they're going to eat a lot of salt, right? And almost all autistic kids eat a lot of salt. That's because they understand and sort of innately know that it will help neutralize proponic acid. And so they eat a lot of salt as a result. And your kiddo probably eats a lot of salt. It's funny when I'm working with, it's not funny. I mean, it's just this whole thing is we need to get a handle on it. And it's, out of control. But when I'm talking to a family, I can sort of play Karnak, right? And I can always tell them, hey, I'll bet your kid likes a lot of salt. And this is why, because of proponic acid. All right, so in summary, the endocannabinoid system is our master regulatory system. It is involved at some level in every process in your body, every management process it's intimately involved in. It's involved in calcium, it's involved in oxygen, it's involved in everything that you can think of. It is involved in. Research it on your own. I mean, it's fascinating. And why it's not being taught. Quick story. The endocannabinoid system right now in the United States is taught in one major university at the graduate level. That is University of Maryland, and they have a master's program. It's kind of like a nursing program, and they'll teach you kind of about medical marijuana and cannabis. They won't really teach a lot about the pharmacology of the system, a little bit, but there's no PhD level program on the endocannabinoid system yet. There's no research being done here. You have to have a PhD program in a university to really do research. You got a bunch of, independents like me, and you've got some independent PhDs that might be working for a lab or a, company that are researching this, but the endocannabinoid system needs to be deeply and heavily researched, and that's just not happening right now because no universities are studying it. My relationship is with the University of Mississippi. Again, if any of you guys out there want to help, right now we can turn this $2 million, turns it up at University of Mississippi. So if you're out there and you want to make a real difference in this science that's emerging, drop me an email, chip@newpharma.com. Ask Carrie for my cell phone number. Let's have a conversation. I'll plug you into our situation at University of Mississippi. But Dr. David Colby there is, working on the curriculum for a PhD level endocannabinoid system program, and that needs to happen in order for research to happen and all that. So anyway, there you go. The endocannabinoid system is dysregulated in autistic people. So it's, again, the markers, I can measure blood, and I can just show right off how this is dysregulated. The endocannabinoid system works with the gut biome to establish nutritional satisfaction. So if you're not getting what you need from the food that you're putting in your mouth, then the endocannabinoid system is going to understand that. It's going to allow you to develop a gut biome, and it's going to try to manage that within reason. Most of us are completely out of control in our gut biome right now, and our endocannabinoid system is overwhelmed. So it's almost unmanageable, this situation that we put ourselves in. Autism genetically alters genes associated with recognizing certain fats. So again, if I alter FADS 2, you're not going to be able to delta 6 desaturase, and you're going to have a whole lot of problems. And that's kind of what happens. You're not going to be able to defend yourself against the bacteria. And that's what it's not autism genetically alters, it's the bacteria associated with autism genetically altered. Okay, so this results in these fats not being synthesized. And again, if you look at the pathology of autism and endoplasmic reticulum and the stress that's associated with autism in the endoplasmic reticulum, it's because the endoplasmic reticulum is not clearing fat. Okay, they get stuck because of what's going on. These fats are precursors for immune mediators that are staying there as fats, not being turned into immune mediators. These immune mediators have to be mimicked by gut products like butyric acid and propionic acid, which probably cause autism. These gut products cause autism in rats. All right, so there you go. That's a little bit of a dive down the rabbit hole with autism and the endocannabinoid system. There's so much here. But again, the pathology, we're not going to fix, let's say, autism through our understanding of the endocannabinoid system, but we are going to offer ways to help symptoms and sort of improve situations through our knowledge of the endocannabinoid system. The way that we're going to, let's say, treat the cause of what's really going on with autism, though, is to understand the bacterial hijack. And really we need to research that. We need to genetically study that. We need to come out with some effectors and see if we can move the needle on that. But that is a research effort, boys and girls. It's, we're going to keep doing what we do. I've got my PCR. I can test people. I can keep, sort of doing what I do. But this needs to be done in a bigger system, bigger labs. This needs to be way, way more formal, right? So hopefully everybody's getting that, understanding that. I say that at the end of every talk that I put out there publicly, a call to action, if you will. If you want to help, contact me. Lots of ways for you to help. Anyway, see you guys. Thank you. Thank you to Carrie for allowing me to do this, to get the word out. I think this is important. Hopefully you guys will find it important as well.